Recording in progress.
Studying for tomorrow's exam, huh? No class. କିଛି ଆଣିଛନ୍ତି କି? କାହିଁକି? ଖାଇବନି?
Hello. So this is week 3 of machine learning, and so my voice audible?
Yes.
Yeah, yes, please.
Yes, sir. Thank you. Not sure like why two devices are getting connected same time. I think it's better now. Yeah. Can you hear me? No?
Yes, we can hear you.
Okay, perfect. Yeah, so we'll start with the problems from week 3, of course, of the previous year. And I think the solution for week 1 and 2 is released, I guess. So hopefully you had, sorry, let me fix this. Yeah, I hope you should be able to hear me now. Or is there some echo still going on?
No, sir. No echo.
I'm hearing my own echo. I don't know, like this is the problem for every session that I take. Hello. Yeah. I think now it's audible somehow. Yeah. Okay, so let's start with the problem 1. And I hope I'm audible.
Yeah, yes.
Yeah, okay. Let's start with the problem 1. Yeah, so in do you have any doubts in week 3's content, or like week 1 and 2 content or anything like that? So we can start with the doubts and then we can move up to the problems.
So KNN had one doubt. This
Yeah.
when we include more data points, does the bias term increase or reduce? Just wanted to understand that.
So your question is like, does the number of data points affect the bias
Yes.
in the model, right?
Yes.
The answer should be like, so if you like go to the basics, like bias is something like so bias is something like if a model is getting biased towards certain things, it's like if you're training a so if you're training a, let's say, a classification model with the cats and dogs, and let's say you put a number of like more number of cats instead of dogs, so the model will be biased towards cat. So like so if you increase the number of data points, yes, the number of data point does affect the bias in the kernel algorithm. But like yeah, so if you increase the number of data points, it will I guess it will decrease the bias. It will help reduce the bias, because the more the number of data point is, it will the model will make, so the model will generalize better for more data points. It's like how do I put it? So let's say like you are like learning how to identify cats and dogs, and let's say you are shown like 8 pictures of dogs and 2 pictures of cat. So you'll not be able to learn how exactly a cat looks like. But if I show you like same ratio but in different like numbers, it's like, let's say I showed you 8,000 number of dogs and 2,000 number of cats. Even if the number of cats is significantly lower than number of dogs, but you still got 2,000 number of cats to look at before like deciding if it is a cat or dog, like we were giving you a test. So of course, like more number of data points generally helps reducing the bias, like you will not be biased towards a dog or like any other thing. So but like in conclusion,
कंपोनेंट तो बोला क्या हुआ, तुम बात किया था उसके साथ?
सर आपने कहा था वो बात करेंगे डिजिटल
ना नहीं, जो तुम्हारे इंस्ट्रूमेंट के लिए ना कंपोनेंट के लिए,
इंस्ट्रूमेंट कंपोनेंट दोनों
जो कंपोनेंट है तुम जो बोला था कंपोनेंट के,
so yeah, so number of data point is more, it will help reduce the bias of the model. Yeah.
Okay, sir.
Any other doubt, like fundamental doubts? Yeah. Okay, so I'll start solving the question. I think I said last week that I will be covering some of the basics of that week before explaining the questions, but unfortunately I couldn't go through the contents of week 3, so I'll try to do that in the next week. But like as you can see, like the topic is mostly linear classification and logistic regression, and then there is LDA, which is linear discriminant analysis, and yeah, so it mostly is about that. So I hope like everyone is clear with linear classification and logistic regression. So in short, linear classification is used when we know that data is linear. So for example, so the example of linear data in our real world is that is like, let's say, the strength of your teeth with respect to the age. The relation between the like the strength of your teeth with respect to your age is the relation between them is linear. linear, as I say, is means like if I don't know, the pen is not working now.
सिद्धार्थ, दादाचा मोबाईल आणि लॅपटॉप घेऊन माझ्या असाइनमेंट पूर्ण करायचे का?
Pen is not working. I don't know why.
പല കാര്യങ്ങളും എന്നിട്ടാണ് നിനക്കെതിരെ പല കാര്യങ്ങളും.
Hello, sir. I think you're on mute.
Sorry.
These questions are already solved in other sessions, sir, previous 2 sessions by different.
Oh, sorry.
These questions were already covered in other earlier sessions. So,
Okay, so the Tuesday session.
yeah, yesterday's session also means.
Okay, so yesterday session. No, I think there are 3 live sessions going on for this course, and we were told that like to like just solve the previous year questions and any other doubts that students have. So what happens is that in a course, like the professor like basically teaches the theories, and in every week like we have to come down and like solve some problems regarding the theory that has been taught. And so they should have been providing a set of questions for us to solve, but what they are doing is that they're saying that you can just directly solve these questions, solve the previous year questions, and which will be similar to like solving a set of questions. And so that's why like we all 3 have the same set of questions, and we are supposed to solve it in 3 different sessions, and people can join any session that they like to join. And this is more like an interactive session, so that you can ask questions. That's why like they assume that there will be less number of people in each session. That's why like it's divided into 3 sessions. It's not like 3 different sessions will cover something very different. It will be very similar, and you have to choose only one session and join that in 1 week. I can change like the content, but I don't. So we don't actually interact among the TAs. So that's why like it will be similar for all 3, us 3 of us.
Your session
Sorry.
will be all on all Tuesdays, is it?
My session will be on all Tuesdays, and there are other 2 sessions, I guess. I'm not sure which day. One is on Sunday, one is on Monday or Wednesday. Somewhere between that. Yeah, so the idea is to make you attend at least 1 session in a week, and not exactly like ask you to attend 3 sessions, which is a lot of sessions per week. Okay, so I think I'll be solving this question. If you have already solved these questions, and if you don't have any doubt, you can drop the call. It's fine, because I will be solving these questions.
Sir, can you explain,
Okay.
please?
Yeah, I'm explaining. Okay, so linear function is like the linear. So I was talking about the summary. So linear is like when x equal to age and y equal to strength of bone, and as you know that like it linearly varies. So in this case, you can use linear regression models, and the second thing is the logistic regression, which is you have some sort of non-linearity, like x and y is not actually linear. It's like some sort of non-linearity is there. For this case, you cannot use a linear function, like the y will not be equals to mx plus c. So then you have to use the logistic regression, and you have to assign some sort of non-linearity on top of this to make it learn this function. Okay, so coming back to the questions, the question says which of the following statement about distant boundaries and discriminant function of the classifier is true? One or more choice may be correct. So option 1 is in a binary classification problem, all point x on the distant boundary satisfy this one. Delta 1 of x will be equal to delta 2 of x. In option B, in a 3-class classification problem, all points on the distant boundary satisfy delta 1 equal to x equal to delta 2 equals to x equal to delta 3 equals to x. And in C, it is like this condition 1 equal to 2, 2 equal to 3, 3 equal to 4, 3 equal to 1. And D is like let a point, let the input space be at the variant. If x doesn't lie in the distant boundary, there exists epsilon such that all input y is satisfying y minus x less than equal to epsilon belong to the same class. Okay, so if we take the question, so in a classification model, so let's say it's a binary classifier, then the classifier's distant boundary, let's say, looks like this. Okay. This for class A, this for class B. Okay. So it's saying that if a point lies here on the distant boundary, then delta 1 of x should be equals to delta 2 of x, which is true, because like if it is here, then the probability of this belongs to class B is much more higher than this belongs to class A, because it's in the other side of the distant boundary. So if it is in the distant boundary, then this statement stands true, like the equality holds if it is in the binary classification and if it is in the distant boundary. So option A is correct. So option A is correct. Coming to the option B. In option B, what we are saying is that there is a 3-class classification problem, and let's just do it like this. Okay, there are 3 classes, A, B, and C. So all points on the distant boundary satisfy this. See, not all points satisfy this. If it is this distant point is here, the equality will be for this will be delta. Let's say this is delta 1, delta 3 in this region. Let's say. So for this point, it will delta 2 will be equals to delta 3. It will not be equals to delta 1. So this equality will hold only for this point. At this point, delta 1x will be equals to delta 2x will be equals to delta 3x. Okay. So this will be incorrect. B will be incorrect because this is not all. So it's all point. This is not true for all the points. This is true for one point. Then coming to the option 3, this talks about this one d1 d2. So this d1 d2, d2 d3, d3 d1. So the equality holds at this 3 point, similar to this d2 d3, and here it will be d1 d3. Here it will be d1 d2. So hence option 3 is correct. So I hope we are getting the solution. Option 4 is let the input space be r to the power n. So the x belongs to r to the power n. That means the dimension of input is r to the power n. If x does not lie in the distant boundary, so let's So if x doesn't lie in the distant boundary, that means this is your box. This is your x. Let's say x doesn't lie in the distant boundary. There exists an epsilon greater than 0, such that all the input y satisfying this belongs to the same class. So what it is saying is that you take an epsilon value, and so this y minus x mod is equivalent of saying like in the epsilon neighborhood around x. So if you take a epsilon neighborhood around this x, like like of radius x, so epsilon. If you take a epsilon neighborhood around this x, all this point, and if x belongs to class A, let's say, all this point y minus x is then less than equal to epsilon will also belongs to A. That means it is saying that if you take a point which is not on the boundary, there exists a epsilon which is very small, which might be very small. So in that epsilon neighborhood, all the points will also be belonging to the same class A. So this is true because even if the point lies here, there can be a small epsilon you can build around this x, and in that entire neighborhood, all the point will belong to the x. If it is on the distant boundary, then the equality will hold. If it is not on the distant boundary, we can find a point that will act like that. Okay. So this is a solution to question number 1. I hope you understand the question, like a solution. If you don't, you can ping in the chat. And also, like, if you have already understood the solution, you can read the question number 2 and try to get the question. Okay. So it's all question number 2. Question number 2 is saying that the following table gives the binary ground truth level for yi for 4 input xi. Not given. Okay, not given. We have a logistic regression model with some parameters values that compute the probability pi. That the level is 1. The compute the probability pxi. That the level is 1. Compute the likelihood of observing the data given this model parameters. Compute the likelihood of observing the data given this model parameters. The likelihood of so yeah, okay. So what it is, the question is telling is that, so let's say you have a model like this. This is the input x, and there is some w, and x not given. We have a logistic regression model. So here you are getting wx, and you are adding something. Then you are wx plus v, and we are getting this output, and the output is, let's say, 0.8, while the actual y is 1. Then we are getting 0.4, actual y is 1, 0.2, actual y is 0, then 0.9, actual y is 1. Okay. So this is setting, like you have input, you have parameter, you have 2 parameters, w and v. Then you have a non-linearity here. For logistic regression, it will be sigmoid. And you are applying this, C. Okay. So you are applying this sigmoid to the non-linearity, and you're getting this x and y pair with some parameter values that we don't know, that computes the probability px that the level is 1. Compute the likelihood of observing the data given this model parameters. So the likelihood of so you must have known the likelihood maximization that we do. So we maximize the likelihood of the data, like the likelihood of our predicted data as compared to the true level, right? And the formula for likelihood is like this, like P of, so it's like binary like binomial equation. So P of xi, so probability of xi and the probability of P of xi on minus yi. So it's like a probability of success. This is the probability of success. P of success. And this is the P of failure. This is for one case. So if okay, so binary ground truth level, so there is just one neuron. Okay, so this is like this is like the probability of success and failure. So let's just put y as of now. So let's just y. So this is, so no I is there. So this is your binomial equation where we first calculate the probability of success, and this is the probability of failure. So it's like if you are like tossing coin for like 4 times, what is the probability that 2 times it will be head? So probability of head times 2, and probability of tail times the rest, like 6 minus 2 or like that. But since we're like dealing with this I, so I'll just go back. Yeah. So like now let's say like we have these 4 cases. So for the likelihood, the likelihood of the formula would be, we'll add a pi here. It will be I equals to 1 to n. So pi is, it will be I equals to 1 to n. And so this is the formula for likelihood. And we maximize this likelihood. So when we maximize this likelihood, we equate this to 0 and we get a solution. And since we are just calculating the likelihood, so we'll just put the values in here and you'll get the solution, I guess. So P of xi is 0.8. Yi is like a 1, and this 1 minus 0.8 is 0.2, but it's 1 minus 1 is 0. Second is 0.4 to the power 1, and second will be 0. Third is 0.2 to the power 0, 0.8 to the power 1, and fourth is 0.9 to the power 1. And these are all multiplication. Sorry. And if you compute this, will be 1. So 0.8 times 0.4 times 0.8 times 0.9. And if you compute this, it will come out to be, let me try, 0.8 times 0.4 times 0.8 times 0.9. It's coming at 0.2304. 0.2304. Which option is that? Yeah, B. So it will be B. You just have to put the likelihood formula and you will get your answer. And I hope like everyone is comfortable with the likelihood calculation and likelihood maximization. I think it was covered in one of the probability sessions. So the next one is an easy question. Which of the following statements about logistic regression are true? So option 1 is like it learns a model for the probability distribution of the data points in each class. Second is the output of a linear model is transformed to the range of 0 to 1 by sigmoid function. And third is parameters are learned by optimizing the mean squared loss. Fourth is the loss function is optimized by using an iterative numerical algorithm. What do you reckon? Which one should be the answer? I have my answers. So in logistic regression, first is like, as I said here, the logistic regression here. So here is your linear model, like you take X, you multiply it with the W and you add the bias and you get the linear model. To make it non-linear, you have to add a non-linear function on top of that, right? So here the sigmoid comes into play. So what they are saying is that you can approximate almost any function by applying this sigmoid in a nested way, in nested network. So that's why we have this setting, like we have this linear model, and we're just adding sigmoid on top to make it logistic regression. So this option is correct. Okay. And so when your input is 0 to 1, you don't actually use mean square error. That's for regression. What you use is cross entropy. So, okay. And cross entropy for binary classification problem, you use binary cross entropy. So this one is not correct, because we're eliminating the easy ones. The third one is it learns a model for the probability distribution of the data points in each. So the LDA does that. The LDA learns a model for the probability distribution of the data, but not regression. What regression model learn is this non-linearity on top of this linear model. Yeah, so we can use the binary cross entropy, or like people also use the log likelihood, maximizing the log likelihood of the uh, data points. So the rest of like option C is incorrect. Option A is incorrect and option C is incorrect as well. Option D, the loss function is optimized by using an iterative numerical algorithm. Yeah, so this one is a bit controversial. I'm not sure like how this D is true, because the given solution to us whether D is true, the loss function is optimized by an iterative numerical algorithm. But it is not a numerical algorithm. I think it's the gradient descent algorithm that people use to solve this sort of optimizing the logistic regression problem. Maybe some variation of numerical algorithm can be used, but not all numerical algorithm can be used to solve this problem. So if you consider some of the numerical algorithm, then it's fine, but all of the numerical algorithm cannot be used to solve logistic regression problems. So the solution is wrong, but technically it should be. So the solution is correct, but technically it should be wrong. But yeah, so yeah, the benefit of doubt should be given to the students. I mean, the person who didn't frame the question. Okay, so coming to the question number 4. Yeah, so meanwhile, like if you are not getting anything, you can ping in the chat or you can speak up. Just look at the question number 4, and I'll come back in a second. You can put in the chat, and I'll just get the door. Someone is there. So these 2 minutes. Okay. I got to answer 1 and 4. Yeah, I'll see the question first. Okay. One, 3. One, 3, 2, 4. Oh, okay. There's a the solution of the last question, right? 1, 3. Okay. Yeah, we can solve this question. Let me just create some room here. So someone is asking like, is there a recording or something? Yeah, so the recording is there. I'll just send you the link so you can refer to this channel. For accessing the recordings. Okay, so let's just solve these questions. This question. So it's saying that consider a modified version of the linear regression given below, where k is a positive function, beta and beta 2 are the parameters. So beta 1 and beta 2 are the parameters. That means in a model, so your y is like p of x sort of thingy. So it's dependent on x. Y is dependent on your x like this. So this linear combination of x and your parameters gives rise to this one. So it is asking her to find the p of x. That means to find the y, sort of. Okay. So first we'll start by like expanding this equation. So this is log of 1 minus p of x by k p of x equals to beta 0 minus beta 1 x. What you do is that you put e to the power x both the sides. E to the power log will cancel each other, and this will be 1 minus p of x by k p of x will be equals to e to the power beta 0 minus beta 1 x. Okay. So what you do is that then you again transport this 1 minus p of x equals to k p of x e to the power beta 0 minus beta 1 x. Okay. Then so p of x so 1 first term k p of x e to the power beta 0 minus beta 1x plus p of x, right? That implies 1 equals to take p of x as common, then it will be k e to the power beta 0 minus beta 1x plus 1. Okay, that implies whole implies p of x will be equals to 1 by 1 plus k e to the power beta 0 minus beta 1x. Okay, and p of x will be equals to, let me see the options. Yeah, so it will be 1 by 1 plus, so if you take k e to the power beta 0 by e to the power beta 1x, and to work this out, it will be 1 by e to the power beta 1x plus k e to the power beta 0 by taking this addition by e to the power beta 1x. That will be, if you just put it like reverse it, it will be e to the power beta 1x by e beta 1x plus k e beta 0. The previous problem, likelihood distance. Can you tell me the number? Like, so yeah, so let's just, yeah, this is the final solution, and this is option C. Yeah, just straightforward solution. Just need to work things out, and that will be fine. Which one are you telling? So there's a guy like asking previous question. Yeah, we'll come back to that in a while after we're done with all the questions. Okay. Question number 5. Consider a Bayesian classifier for 3-class classification problem. The following table gives the class conditioned density f of kx for 3 classes, k equals to 1 to 3 at some point x in the input space. Note that pi k denotes the prior probability of class k. Which of the following statements about the predicted level at y are true? must be class 2. If yes, sorry, I guess not. Yes, probably. Yeah, so the question is considered a Bayesian classifier for 3-class classification problem. Okay, a bit bigger. Not sure if I'm going too fast or not. Yeah. So it's a Bayesian classifier, and it's a 3-class classification problem. The following table gives the class condition density. That means class condition density means so density of a data point X is something like how dense a data point is like when you say density of data point is given some class, it's called class condition density. That means what is the probability of finding a data point X given that belongs to a certain class. That means like we're trying to find a data point given that it belongs to some class. So it's like saying the proportion of class 2 is like 20%. The proportion of class 3 is like 0.5%. The proportion of class 1 is 0.15%. So it's f of k. The following tables, it's a class for three class classification problem. The following tables give the class condition density f of x for 3 classes k1, k2, and k3 at some point x in the input space. So if there is the input space is x, the probability, or like you can say the density, the class condition density of data point x is given by f k of x, and these are the values. At any point, the class condition density is this, like the probability of finding a value, like probability of picking a data point x, given that their class is 3 is 0.05, given that their class is 2 is 0.2, and all these things. And so note that the pi k denotes the prior probability of class k. Okay, so what is the prior probability of class k? And so the question is, which of the following statements about the predicted level at x is predicted level at x is that true? One or more choice may be correct. Which of the following statement about the predicted level x is that true? So pi k denotes the prior probability. So do you know this term prior probability? So prior probability is a term like, so it's like the probability of a data point before you have trained the model. It's like the prior is the probability that it came with, like the probability of finding. So if you're saying probability of find y given x, so it's like prediction, right? You're trying to predict the probability of y given x until we equal to probability of x by probability of x given y sum. So this is a base formula, and this is the Bayesian classifier, right? What we're trying to say is that, and this is called prior probability. Prior probability is something you get before you have trained the model. It's called the prior probability, and this is called a posterior probability. Something like this is called posterior. This is called posterior. I'm confused, but this is called prior. The prior probability that you have. So let's say pi k is the prior probability. Then the options are, if 3 classes have equal priors, the prediction must be class 2. And second option is like that, C is there and D is there. Okay, so let's look at the prediction formula for a Bayesian classifier. The formula for a Bayesian classifier is argmax of fk of x into pi k. Okay, argmax k. Okay. That means in a Bayesian classifier, we are maximizing the prior as well as the density. So you'll get the data point which will maximize this one. Okay, and in option A, it is saying three classes of equal priors. So if this is equal, these all are equal, the prediction probability or the max. So the class with the highest probability will be the our target class. So if this is higher or lower, the value of this will decide which is the correct class. So if the priors are the same, you can see the value of 2 is the highest, right? So 2 is the highest. Hence, if these three are like this for all k equals to 1, 2, and 3. If this is same, then the decision will be depending on this. And since 2 is the highest one, 0.2, then option A will be correct. If three classes have equal prior, the prediction must be class 2. Then we look at option 2. Option 2 says if pi 3 is less than pi 2, that means pi 2 has highest. Like pi 2 is greater than this, and pi 1 is also greater than pi 2. So we know that like pi 2 greater than pi 1, pi 3, but we don't know a relation between pi 1 and pi 3. So we are saying that the prior of pi 2 is more than pi 1 and pi 2. This statement says the same. The prior of class 2 is more than class 1 and class 3. The prediction may not necessarily be class 2. So if the prior is highest, so this is the multiplication of prior and this fk of x, right, the density. If prior is highest for class 2, then this is already highest for class 2. So then highest into highest will always be highest. Okay, so in this case, answer will be always be class 2, but it is saying that not necessarily. Hence, this will be false. Okay, so the third is if pi 1 is greater than 2 of pi 2, the prediction could be class 1 or class 3. See, this will be like a true statement, because let's say pi 1 is greater than 2 times of pi 2. Let's say 2 times of pi 2, then so greater than 2 times of pi 2. So let's say it is like, let's say pi 1 plus epsilon is equal to 2 of pi 2. It's saying it is greater than, not equal to. That means if I just add some value, let's say some very small epsilon, let the equality holds at that, then that implies pi 1 would be 2 pi 2 minus epsilon, right? So if I put this into this formula, prediction for class 1 would be pi 1 into f1 of x. f1 of x is 0.15, right? And this is equals to 2 into pi 2 minus epsilon into 0.15. On the other hand, if I calculate the p2, it will be pi 2 times f2 of x is pi 2 times f2 of x is 0.20. Okay, so if I expand this, it will be 0.3 pi 2 minus 0.15 into epsilon. Here it will be 0.2 pi 2. Okay. So if you compare these two values, okay, then if 0.15 epsilon is less than 1, that implies class 1 is the winner. Winner means the argmax, in the argmax, class 1 will have the highest probability, and the answer will be class 1. So and I can choose a very small value of epsilon, like 0.01, and it will be like 0.0015, and it will easily be more than this. And since we do not know about the pi 3 can be 3 times of pi 2, and this will also be pi 3 can be also ideal candidate. So the question that I'd ask, like, if phi 1 greater than pi 2, the prediction could be class 1 and class 3 is true. It can be class 1 or it can be class 3 is true. And the last is, if pi 1 greater than pi 2 greater than pi 3, the prediction must be class 1. The answer is no here, because if pi 1 is more than pi 2 and pi 3, it might be like very less. If I just say that pi 1 is equal to pi 2 plus a very small value of epsilon, then pi 2, there can be very negligible amount of difference between pi 2 and pi 1. It can be like as close to 0. It can be as close to 0. So just saying this statement is just better than this will not change the fact that, like, it can be very small change, and with that small change, it will not be able to overcome this probability for this 2. So hence the argmax will pick class 2, can pick class 2. So this must be class 1. If it is like maybe class 1, if it is maybe, then it can be true. But since it is a must class 1, this will be false. This gives like A and C as the answer, final answer. Any doubts in this? So doubt, you start asking questions, and it's a very long sort of. There's a question down little. Yeah. So next question, 5 answer. If you want to see the 5 answer, so it is A and C. Okay, so I'll just go to the next question now. You want to see the solution, or you just want to see the answers? No answer. Anyway, yeah, got it. So question number 6, I'm not gonna solve because it is time consuming. Also, it's very straightforward. So what you do is that, so it's saying, what it's saying is that this is the x and y and y1, like, x1 and x2 are this data points and y is the target. So it is saying that this is a form of the logistic regression model, and this is the probability of xi given this point x. So what you have to do is that you have to find this parameter beta 0, beta 1, and beta 2, which has the like lowest loss. So what you do is that you have to take this parameter values and put it there, put it here, and get the values for this one, then this one, and this one. So you have to put it here. So after putting it here for option A, it would be like 1 by 1 plus e to the power minus beta 0 plus beta 1x plus beta 2x. So it will be x1, x2, okay, not just x. Yeah, so you take this values. So you take the value of beta, so you put it there. So it will be like 1 by 1 plus e to the power minus beta 0 is 0.5 plus beta 1 is 1.0 into x1. x1 is x1, let's put x1. Beta is 2 into x2. What you do is that you take x1 and x2 values for these 4 values and you put it and you try to find the cross entropy loss, right? Okay, likelihood. So you have to find the likelihood, log likelihood of this, and you'll find like 4 points. And you take it average and you'll get a number 1. Similarly, you get number 2, 3, and 4. What you have to do is that you have to find the this. You have to find the highest log likelihood. So if you get this number for each option, you get the highest one, it will be fine. It will be like done. So here the log likelihood formula will be applied after getting this value. So the log likelihood formula would look like beta 0 and beta 2 will be equals to the summation of I equals to 1 to n log of 1 minus p of, you can write it correctly, log of two will be equals to summation of I equals to 1 to n log of 1 minus p of xi plus summation of I equals to 1 to n yi log p of xi by 1 minus p of xi. This is a log likelihood formula. I think most have heard it, like learned it earlier. So p of xi is this one, and you put that and get a value. So what you can do is that you can do it in program. Write a program for that, and you get the code output. And for your solution, like I can give you the solution. Option C will be the correct answer. Okay, so I'll not be solving this. It's too time consuming. Yeah, so there are 4 more questions, and all the 4 questions are sort of multiple choice theoretical questions. So let me find any problem questions as well, so that it will be easier for you, like it will be beneficial for you. So is there any, let's go to, there's a non-graded question. I think just let me look at the questions first. There's not like much question left. I'll try to solve one theoretical questions maybe, or if you have any doubt, any specific doubts regarding any question, you can ask. So if you don't have any doubt, we can end the session for today. And the rest of are like theoretical questions, and I don't see much theoretical questions in this week's assignment. Yeah, so yeah, we can end the session for today now. If you have any doubt, you can post in the discussion group, and the video recordings will be shared in the YouTube channel that I pinged in the chat earlier. If you haven't got that, you can always go to the public sheet that is shared with you all, and you can get the links for all those things. Okay, so I'll be ending this session now. Talk to you next week.